wanted to talk a little bit about, I'll give a little bit of introduction. We have two speakers and two panelists. We'll have about 60 minutes of presentations followed by about 30 minutes of Q&A. There will also be a little survey in here, all right? And so you might want to have to, oh, that's loud. And I'll tell you how that's gonna work out. So first, let me give you an introduction about myself. My name's Rick Riss. I am an analyst at ARC. I have a background starting with process control systems. I worked for Foxborough Company for 20 years. I designed and built and implemented control systems for every dangerous reactor you can imagine, distillation columns, compressor surge controls. I just got in the middle of all the other projects that everybody else stepped back one step from, all right? And so I worked for Foxborough for 20 years, mostly in the oil and gas industry. In '96, I quit. I became a one-man system integrator and consultant. I continued to work for Foxborough Company and Schneider Electric. In fact, I worked on testing the control systems for 8 nuclear power plants that went into China. I also worked for a German company called Windtest because I was more interested to get into a little bit of renewable energy. I moved to the town of Princeton, Massachusetts, where I designed and built my own net zero grid interactive house. So I have some interesting, smarter than average home stuff. I also became a light commissioner in that town because I had a little background in wind turbines. The town of Princeton has a very small light department, PMLD. We have 4 linemen and 1 manager. We have no substations. We have no gas stations. We have 2 1.5 megawatt Furlander wind turbines that were put in about 11 years ago. So we own and operate those wind turbines. We have some responsibilities to manage that grid, which gives me, I think, a little bit of a unique perspective. We're currently, as a muni, I get to be involved with a lot of the electric utility industry and connect to the other municipal electric companies within the New England area. And it's been amazing over the last 5 years to see a transition where all of the lobbyists were fighting for new natural gas pipelines and avoiding regulations. And it's kind of got to the point where they lost that battle. There's a Massachusetts S.9 regulation that requires all of the munis to be 50% non-carbon emitting power portfolios by 2030, 100% by 2050. As a result, there's been huge changes. We're very much trying to support electrifying our town. As you can imagine, a rural town, we have no gas. Everybody heats with oil. We're trying to transition all of that oil to mini split heat pumps and move that out. We have some EV chargers, but we're also trying to, in our path to get to 100% non-renewable, we're trying to build out a new, we're trying to build out our low voltage or medium voltage line to the adjacent town of Sterling because we're selling them some of our wind power. Occasionally those wind turbines produce more power than our town can consume. And so we push that power out to the Westminster substation, which goes over national grid lines that charge transmission fees to the town of Sterling when we sell that power. But if we connect directly to them, we can sell that power directly behind the meter, so to speak. We're also looking to build the 1 to 4 megawatt solar field, and we're looking to purchase about 1 megawatt of the offshore wind project from the Mayflower Wind Project. There's some I think 30 gigawatts of offshore wind currently in the pipeline offshore. The first projects are already under construction. You know, these are projects being built. They're coming out at about 500 megawatt collections of offshore wind turbines with an offshore substation and there are, however, some problems that you find in the New England grid. You know, we're probably got a lot of engineers here, probably have a lot of ideas about what technically can work for new possible generation. Can you do it with solar and renewables? Can you do it, but you must have nuclear with natural gas have to be an essential thing? And I'm going to give you a survey question. You'll be able to comment on that. But one of the things that I learned as a commissioner is there's a lot of complexity in the the policies, the regulations, the economics, as well as the technical side that need to be taken into consideration of how that's all going to unfold. And there's still plenty of uncertainty how it will unfold. At one of my recent NEPA meetings, New England Public Power Association, I heard the CEO of ISO New England, Gordon Van Wheely, talk about what the problems are and what's happening, what he's projecting. In the queue of organizations that are bidding into the wholesale energy market by 2030, approximately 65% of all of those bids are offshore wind projects. 30% of them are solar projects, and about 5% of them are gas. Now, this is the new generation being added to the existing generation in the grid. That means hydro and existing gas plants. We've basically moved to pretty much all of our coal plants are shut down. They got replaced with gas plants. Now there's a transition from gas plants to renewable power. Carbon capture and storage is possible I'm not sure if it'll be possible in that time frame. Now, Gordon, in his presentation, described what it's going to need to manage. And Gordon says there's a lot of problems with the current policies and regulations that will prevent that from working smoothly. In particular, some of those problems are, you can imagine that, do you expect all these offshore wind farms to basically be able to fund all the transmission lines internal on land in order to distribute that power to the population centers? Who's going to pay for those transmission lines? Yeah, maybe the wind turbines pay for it to get to shore, and that's very easy at first when they can come to a shutdown coal plant and a few other places where there's where it's a kind of a natural place to connect. He suggested that unless there are new markets and new regulations and policies, that it's highly likely that we will get to a situation where there will be rolling blackouts unless we get that. Now, he was kind of a threat to FERC to help push together those regulations. Keep in mind that we have 3,300 utilities in the United States, 55,000 substations, tons of regulations at state and regional levels, and we have FERC and NERC, kind of our major federal regulators. In any event, the markets he thinks he needs are capacity markets, and those capacity markets would be markets that would allow revenue to stream in and help to pay for those transmission lines upgrades and also pay for grid storage. So in any event, that's kind of just some context of where electric grids are from the point of view. At ARC, I cover the markets for grid automation, grid asset management, and being a light commissioner and getting this connection as if I was a utility, is a very useful thing to give me that broader perspective. So we talk about, all this, so I talk a great deal with the suppliers, GE, Hitachi Energy, Siemens, Schneider Electric, S&C, SEL, all of these suppliers. We have contacts with them. We put markets together. I also have been producing market studies on hydrogen and nuclear power, making some projections of what paths are going, what the obstacles are, and what the opportunities are. So in any event, that's kind of the story, and let's keep moving on. There is a survey here. You probably, if you can't read that QR code, you need to copy that number down, 1351455, and go to slido.com and type that number in. All right. If you can read the QR code from your chair, well, you don't need to do that. All right. In any event, this is basically just a simple question of ranking what by 2050 what the major sources of power generation are. And there's probably a few power generations that you weren't necessarily thinking about. Today we are going to have 2 live speakers and 1 recorded interview. I was trying to get Neil Chatterjee, the former FERC chairman and commissioner, to come and speak. He actually couldn't. He actually was considering to come. I was surprised that I would even get him to, somebody like that to come down here to ARC. But he did agree to make an interview, and we'll play that interview. We also have, Bob and Sam that'll speak, and Gil and Jamie that will be on our panel session. So I kind of want to start, I want to ask, just a few days after Russia invaded Ukraine, the IPCC report came out. Now the IPCC report, comes out every year and some people read it. I want to know how many people read all 3,500 pages? Nobody. Nobody read it. How many people read the summary? Nobody. Oh my gosh. So I'm going to give you the summary. All right. Very short. It wasn't. I'm quoting from someone else who kind of did this, and I thought it was kind of cute. The planet is warming. It's bad. It's us. We're sure it's us. We can fix it. It will be hard. All right. So that's kind of the summary of the IPCC. It's really the same summary that's occurred for many years, all right? And I recently went back and watched a YouTube video. You can search for this 1985 Carl Sagan testifying to Congress about climate change, all right? And I'll tell you what, if you listen to that physics description of how climate change is working and you play it today, it's the same physics. The physics didn't change. Carl Sagan was a physicist. He accurately described how climate change works and how it works today. So today, we've had 37 years since that one presentation. He's not been the only one that described this to political leaders, and obviously political leaders is very hard to make changes. So clearly part of our future electric generation is political in nature and policy and regulation related. So I thought that this graph, which is the main CO2 contributor with CO2, methane is still 14% of our problem. But this is our report card. So since 37 years, we were supposed to be turning that curve around because we started at 285 parts per million of CO2 and we're over 420 now. But it's not actually even slowing down, it's continuing to go up. So this is the report card that we as parents are giving our kids. I don't think it's a very good grade, all right? But it's not impossible to turn this curve around and start to eventually flatten out our CO2. I'm not going to talk too much about this, but this is kind of our current energy balance, at least in the US. The energy balance in the US, you can see on the left-hand side, these are all the sources of energy, not just electrical energy. And in the top, you can see what makes our electrical energy. And Lawrence Livermore makes these slides every year. You can go back and look at them, and you'll notice that big black line of coal, which is a very big part of our electric generation, is still there, but it was much fatter years ago. So coal is definitely in decline, all right? But if you look on the left-hand side and look at all of our energy resources, and you look at those that are emitting carbon, that's most of them, all right? Petroleum, gas, coal, all right? And the ones that are not emitting carbon are shown more or less at the top. And so part of our problem, if we're going to solve the overall global problem, is to stop putting carbon in the air and methane in the air. And that basically means we need to electrify virtually everything. We need to electrify transportation. It's completely impractical to collect the CO2 from your car and store it in your trunk and drive it someplace to get it, sequestered. So you can see the magnitude of the problem in this slide. You can kind of see this is a suggested solution. A number of different organizations, IRENA, IEA, IPCC, are all suggesting that, well, we're about here worldwide on the left-hand side. And then you look on the right-hand side, this is the power mix that's expected by 2050. And you can see there's massive amount of wind, lots of solar. It shows nuclear making a renaissance, all right, slowly, but not right away, all right? It shows hydropower appears to be less. But the only reason hydropower is a less percentage of our generation in the future is because the total amount of power we need by 2050 triples. And most of the hydropower is already built out. So that hydropower can't expand as fast as proportional to the electric generation.